Yeah, I'd be happy to meet. Do you want to like set up the initial communication around that? Yeah, that'd be great. Mark. Is this the PH? Is this for? Sorry, I'm unfamiliar with the PHP ecosystem. Is this for the PHP software itself, or the PHP like package management, or both? Cool. Cool. Yeah, I think in general, like any sort of outreach to major software projects, I think is good to try to see, how we could get them on board with this. I think that's fantastic. Perfect. Thanks.
Cool. Any other topics, or Mark, do you want to jump into your demo next?
Sure. Yeah. So actually, I'll give a minute in case anyone more on that topic of talking about PHP or any other outreach. Okay, I'll take that as a no. So Matt Spozo and I have been, excuse me, still recovering from cold, putting like an end-to-end demo together for Salsa on showing like the idea of how the things come together. So that is generating provenance, uploading provenance somewhere, something checks the provenance, verifies the hashes, displays information, makes some sort of policy decision. I don't know. I don't think it matters too much exactly what the details are, but just we want something to show this and have some actual code and something to work with, so we have something to build off of. We're still like in the very early design stages and like don't even have like public code yet. That's really working. And we're still kind of hashing through some of the difficult problems. But if anyone is interested in like working on this or contributing, or let us know. I think once we get a little further along, we'll put it on GitHub and like actually start discussing it publicly. But I wanted to mention it to this group in case anyone's interested in joining early. The main thing that Matt and I, just to give it like a status update, that Matt and I just discussed earlier today was the notion around like just kind of like how all the pieces work. I don't think we have to get it right on the first try, but I'd like to try to get something working. If we just have some sort of storage system where provenance is keyed by hash, and anyone can upload provenance, we have the situation that we actually ran into internally in Google, which is that you might have one hash that has a bunch of different entries. Like in some cases, you could even have millions of entries, especially if like people are doing this maliciously and intentionally uploading a bunch of garbage for a given hash. So let's take PHP for the example. If you want to verify a PHP binary, you would have to sift through millions and millions of entries to find the one good one. It's a known problem that we have internally, and so I'd like to try to figure out how to solve that. So that's one of the, I think that's the real big challenge now of like, what is the lookup scheme for provenance. If we store it with the package manager, like you attach it to the package itself, that kind of solves the problem because there's only one and the package uploader just provides it. But we want to build a demo that doesn't require any changes to the package repository, because like we want this demo to be useful for like when we go to PyPy or Maven or npm or the various package repositories, like we have something to show, because right now there's no real incentive for them to make changes. We want to kind of show the idea. So anyway, that's what we're looking at. Trish Hanks?
Oh yeah, sorry. I just wanted to comment that it's a solvable problem, right? And there's one way that we plan to. Is Joshua on the call? I believe he is. There's one way that Joshua and I are planning to write about. At Datadog, we're using this thing called Tough to uniquely associate a set of attestations with artifacts. And you can do it without changing the original package repository. You just need a separate server that hosts this, that makes the mapping for you. You can think of it as a secure mapping.
What is the like the access control or configuration of that? Like who chooses, like for the PHP binary?
Yeah, good question. In fact, let me show my screen just so you can take a look. Of me trying to hand wave about it. Oops, can I share my screen? Is it okay, Kim?
Yeah, go for it.
Great. I know it's a bunch of gobbledygook here, but bear with me. So if you take like this wheel, for example, it's a binary, and then we can put something called custom metadata and stuff, where we can say, here's the in-toto root layout you use, and then here are all the attestations you can find. The classic link files. As for who's allowed to sign this file, that's up to you to define.
But I think that's the actual problem.
In this case, it's machines, and right. What is the problem? Sorry.
Where who signs it and who is in charge of defining its schema.
I see. So okay, let me right. So what you would, in the beginning, if you, okay, let me put it this way. In the beginning, so in this case, we can trust machines because, and I'll get to why. So in the beginning, if you only have a bunch of attestations, right, associated with the link, associated with the artifact, and you don't have the layout, and you trust machines to, so machines do sign this file. So what can happen here? So good, exactly. Machines can give you a unique association between attestations and artifacts, but that gives you no reason necessarily to trust the machine. So how do you double check the machine? Well, in this case, we also associate the rules of the game, the root layout file, as it's called in Toto, that lets you find out that the machine is trying to trick you. In other words, it tells you why these attestations are trustworthy in the first place. Does this roughly make sense? Or in your case, I think, I'm not sure whether SLSA is attaching root layouts yet. I'm not sure about this. So if it's sorry, go ahead.
Sorry, I didn't mean to. So my concern is not so much like the security and the crypto part of it, of like the authorization part, but more of the storage and lookup. When, not to say that's not a problem, but like the problem that I'm thinking about is when we have an artifact, like a file with hash 73C7.
Yeah.
When someone goes to verify it, how do they find these attestations?
Right.
If there's millions and millions and millions of them, how do they sift through them and not have to do an operation that's, O of n for the number of attestations that anyone in the world has ever uploaded?
There are a number of solutions. I'll get to it, but I think Tom has a comment. So
Yeah,
Right.
and I'm sorry, I would use the like raise hand feature, but I'm in a meeting room that doesn't have that. I mentioned something in the notes doc, and that is I'm wondering if we should standardize on the OSV method where they have this this affected package field that includes the ecosystem and then the package name within that ecosystem. Um, at least as a starting point, and like potentially we would need to like further refine it, but like at least being compatible with OSV seems like it would have some advantages.
Yeah, like I said, there are many ways to solve this problem. In fact, something that might be easier to start with right now. So I'm just showing one way that we did it. One way is to use stuff. Basically, someone has to be responsible for securely signing and distributing this, right? Could be the SLSA project in this case, just to show the example. But I think a simpler solution for now would be using maybe Sigstore. I don't see why we couldn't use Sigstore to uniquely associate your artifact with what attestations you're supposed to look up for it. So what you do is you record the attestations first individually on Sigstore. I'm just brainstorming here. I'm not sure whether this would work. Someone from Sigstore, correct me if I'm wrong. What you do is you record the attestations first on Recur, right? And then you associate, and then you record the artifact itself, and part of the metadata for the artifact, permanently recorded now, no one can change it, is what attestations you're supposed to look for it also. And now you have log n lookup, right? It's very efficient.
So the attestations live alongside the artifact, typically in the registry, right? What goes in Recore, I think, is just the record of things like the ephemeral certificate issuance, right? Ah, okay. It can store attestations too.
Now the question really becomes, so I think Recur can solve this. Recur, sorry, someone correct me if I'm wrong, but Recur can store the attestations and can associate artifacts with attestations. Yeah, exactly, record. So Recur. Now the problem I think boils down to, why should you trust the attestations? How do you know which keys you're supposed to use for the attestation?
So that's actually something I'm chatting with some folks on now. I know that at least some of the the signature spec can sort of refer to an identifier for the key, so it can give a hint around what key you should be actually looking for. But I think I know from my perspective, one of the big open questions is who has that set of, who is providing the set of for the end user of like, hey, you should be trusting these keys. How do users know, like, okay, let's say I trust Google's key, I trust this other vendor's key, and so on.
So I guess, so here's, oh, sorry, go ahead.
So I was just trying to look it up. I think there's a SLSA issue related to this question. I personally see a couple of different options. One is if we follow like a CA cert chain model, you could have the OpenSSF could have like 4 different keys, one for each SLSA level, and like OpenSSF could theoretically sign anyone's key as like L1 and L2. And then for like L3 and L4, maybe there's some process that people need to go through, like a security evaluation, whatever. And then once like OpenSSF is happy, they could they could sign those keys for folks. And then the end user doesn't need to care about the specific keys that the builder uses, but instead they just need to root their trust in whatever OpenSSF says. And of course, it could be anyone. It doesn't have to be OpenSSF, or it could be OpenSSF and like other orgs. The same way that browsers have like built-in roots that they trust. Another option, like just to start, is like just set up a GitHub repo and let people check in their keys there.
So just to make sure I understand, right? So in a model like SigStores, where you've got things like the full CO root, right? It would the equivalent of this being something like having a full CO root for each SLSA level, and then as vendors or whoever sort of establish that they're producing things conformant with a particular SLSA level, they can become a trusted delegate of the full CO root for that SLSA level. Is that sort of in line with what you just said?
Yeah, can I had this, like, I want to jump in on both of what you both are saying. So I had this like SigStore trust delegations that like I am proposing that we add in delegations into our tough root for SigStore, which contains information about, the full CO cert that we trust and the recore keys that we trust and so on. And so the proposal in specific, like adding these delegations, what they could do is either they could delegate to another project's root of trust, or they could delegate to exactly what I don't know which room you are. So I don't know what your name is because you're a phone room right now, but
Sorry,
just call him 10F206.
Tom. Okay. So exactly what Tom was saying, where like we could add delegations for levels, and then those delegations would contain your trust. So, and because root signing repository, like our SigStore tough root lives on a GitHub repo, like all of that could be automated with pull requests. And so the idea is that like we would have like a sort of Acme style challenge too, even for like the project delegations, where like if we're delegating trust to a certain project over some namespace in a repository, we say, okay, go sign, blah challenge and put it on your repository. Okay, cool. We trust you to distribute artifacts there and the associated keys. So that's my like strawman proposal about it. But I don't think I would love to hear if someone's super familiar with the SLSA side of this, what they think of like doing something like that. And I probably will get a demo of what I think it looks like on like a toy repository that you could set up for like SLSA levels, and yeah, I'll distribute it.
So so how for this or any other system, like how does this work if you have something like a CI platform like GitHub Actions or Google Cloud Build or Azure Pipelines or whatever, Circle CI, which is one entity that we trust, but then it's multi-tenant and it has millions of different users. And we would probably want to trust each of those different users differently. But so for example, if we want to trust, let's say GitHub Actions to do the build because we, for whatever reason, have analyzed it, we say their architecture is good enough, it meets SLSA 3, let's say. And the provenance that it generates is accurate. But we have, let's say, some users who are like 500 different projects who are all generating literally the same file that output the same hash. How do we kind of sift through that? That's my question. Like, would they all be signed with the same key? Would there be some sort of delegation model?
So I expect it would depend significantly on how you were using something like Actions, right? And so, I mean, one conceivable way, well, in my head, right, would be if GitHub could effectively analyze an action and deduce that it might qualify for a higher level of SLSA, that then when it does the interaction with something like full CO to do certificate issuance, maybe it's hitting their trusted delegate of full CO, and based on the workflow that's being run and its satisfaction of a particular SLSA level, it signs it with the appropriate root for the appropriate SLSA level for that workflow. But that I think it would depend a lot on what you put into your actions, right? So like for SLSA 4 Hermetic, I don't even think there's I don't know of a way of doing that in Actions today. So, I think you would have to effectively, configure your workflows, I think, based on these levels. And, I think that would affect the route that something like a GitHub trusted delegate would then sign with. But that's the picture in my head. I mean, does that make sense to folks? I don't think it's just like, okay, everything going through Actions will be SLSA level X, right? I think that there's some more work involved in that.
I might actually disagree with that. So I think it's important to say that, like, I don't think of the signature over the provenance as like meaning that this thing that the provenance identifies is like necessarily trustworthy, so much as the signature, like if the signature comes from a SLSA level 4 builder, then you know that what is in the provenance is accurate, and then you still need to compare that provenance against some specific policy for some specific use case to know if that's acceptable. And so if we can trust that, like, GitHub Actions is configured such that the provenance always reflects reality, which is like, this is exactly what GitHub Actions did, then it shouldn't matter if 1,000 different projects can like create whatever provenance they want, because, or pardon me, they can't create whatever provenance they want. They can only create provenance that says, this is the GitHub Actions workflow that was run. It was run from this source repo and like produced this thing with this output. Like, that should be true. That should be true, sort of regardless of who does it.
I think what you're saying is sort of a meta level, right? Like, okay, yes, the control plane was SLSA level 4, and it basically is asserting things with a high degree of confidence. That does not mean that the workflow that was run, the things coming out the other side, are SLSA level 4. But the statement that is being made is that what you're saying? The nuance?
Yes. So, like, at the very least, when I think about making decisions about an artifact, that a couple different things come into play. One is the builder level, which is what GitHub Actions would have. Another is the source control level, and for that it matters, like did the repo have like two-party review required? Did the repo meet all the level 4 source requirements? And then further, there are more requirements about the build specifically. Like, is it using config as code? Was it run in the hermetic way? Because you could easily see that GitHub might have a flag where, like, people can say, hey, my build isn't hermetic, so let me do whatever I want. And that's certainly not going to be a SLSA level 4 artifact, right? Does that make sense?
We haven't really said anything about like disaggregating levels between sets of requirements. We don't have separate source and build levels. So I think at the moment we're still talking about a single level, but what's being alluded to is like, I think picking out the properties of a build system, like, is it isolated, right, multi-tenant, single tenant, and having that be sort of established so that downstream consumers, policy evaluators, could say, all of these boxes are checked, but like, the source repo wasn't two-party, so this is going to have to be L3. Yeah, so establishing sort of a common set of build properties, which is effectively the like build level you're talking about, the like max build, the max level a build can qualify for if running on this platform. Yeah, I think is something that could be done in a repo, could be, it just needs to be established and shared, which, we've talked about the ways that can be done.
So one thought, so as somebody who's mostly as a consumer of a lot of this data that's coming in, to say, hey, yes, this thing's salsa. I know one of the big things for us is more along the lines of, did the person, did a key that I trust sign this thing? A lot of the other details are kind of less important for us. Obviously, long term, we do want to sort of say, yes, assuming, GitHub is reporting all the right information, and assuming that, the CI/CD systems are secured a certain way, now we're going to be, but for us, a lot of it's about trusting, like, what developers, what organizations, and so on do we trust to sort of be giving us these things, to be, giving us these artifacts. And a lot of those other things matter a little bit less, because I know for one of the big challenges, right, is how deep do you go with these things, right? Like, are we going to start attesting to, like, the operating system needs to have certain controls around it before we trust the CI/CD system and so on?
I think including like a root of trust or something in that like builder configuration is absolutely, this kind of table states, right? If you're able to validate the, provenance produced by a builder and evaluate its level, you need both those things.
Yeah, and for what it's worth, probably by next week, I'll have a sort of a full end-to-end demo of this sort of thing with OCI. So storing literally all the sort of stuff in OCI. I know that doesn't help out with some of the package stuff, but sort of doing everything and including the materials themselves as signed blobs inside of OCI, and all that sort of stuff, and using Tecton and using OPA to actually validate that the attestations, as well as being able to audit the blobs, if anybody was sort of interested in the next couple of weeks.
Yeah, I think that's great. I think in my mind, that's the best model, and I would like a world where all the different package repositories can propagate the attestations along with it. Yeah, I think that's the best. In parallel, we'll try to come up with something, because what I want to do out of this is like have some motivation for when we talk to other package ecosystems to show them how it would work for their particular ecosystem, and say, like, here's like here's several top-end packages, here's how it actually works, just to kind of like iron out the kinks. Because I know from experience internally within our company, when we went to different organizations and said, like, hey, we wanted you to make these invasive changes to your system to do this, they said, wait a second, you do like some sort of bolt-on system where we don't have to make any changes, prove that it works, iron out the kinks, and then come back to us. And so I'm just kind of anticipating that's what we'll want again, is like, if you could just do it with no OCI without any modifications, that's obviously even better.
Cool. Any other comments on that, Mark? Or
no, I think basically what we'll come. I suspect what we'll do for our first version, Matt, feel free to speak up if you disagree, is just like do something that just works. Like, it's not going to solve the real problems. Just throw something together to show the idea, and then we could kind of like fix pieces as we go. Because my interest is getting something kind of working as soon as possible, even if it's like unwieldy.
cool. Sounds good. I think that is all we have today. There is oh yeah, wait, there is another topic I think, Tom, you wanted to discuss, is about the different provenance formats. We did just publish a blog post on the Google security blog. I can add the link to the meeting notes, and it brought up some questions on sort of feedback on the different provenance formats and the requirements around provenance formats. So Tom, do you want to?
Sure. Basically, it sort of centers around the SLSA requirement. I think it's the provenance is available requirement that says that the provenance should be SLSA provenance. That's the salsa.dev/provenance format. But it's just should. And in the blog post going up, it is saying that like, hey, like distro list is like SLSA level 2. We meet these requirements, and in fact, it is producing provenance, but it's not SLSA provenance. It's a Tecton specific specific format. It does have everything that is strictly required, and that's definitely an advantage. I think my concern is that if we want to have an ecosystem that is compatible and like everything just works, that it would be ideal if everyone were using the same provenance format, because otherwise policy evaluation points need to understand each specific builder's provenance format, which makes scaling hard. And so I guess I wonder, like, should we be more forceful than should in the requirements, or should we have any messaging like really please produce the SLSA provenance? I think, as an aside, Michael, I think you mentioned in Slack that you are working on getting Tecton to produce the SLSA provenance.
Yeah, so on that note, it might just be as simple as taking the chains and just converting it, or otherwise just generating that as another consequence of another task or something like that.
Right, and I should also say that that the in toto bundle format does require that readers ignore anything that they don't understand or ignore things that they don't care about. So it's actually very easy for Tecton to produce both the Tecton provenance, which can have a ton of detail and can be very specific to Tecton, and then also include the SLSA provenance, which will be sort of more generic and consumable by anyone.
At the risk of asking a dumb question, have we looked at reconciling the thing chains did and the thing that SLSA currently is to figure out why it might have gone off and done something different from SLSA in the first place? Because honestly, that format made a lot more sense to me when I first saw it than the SLSA one did. But that's just my personal preference and biases.
So my understanding, and anyone that knows better can correct me if I'm wrong, this sort of came out of what was eventually resolved with the config as code or the build as code requirement that wound up getting clarified in SLSA, the build as code and the build instructions requirements. That currently Tecton does not support build as code, and the old requirements sort of implied that you had to use build as code and that you had to specify a specific entry point that was stored in source control. So the new requirements sort of clarify that at SLSA level, that up to SLSA level 2, that you don't need to use build as code and that you can just record the build instructions. And that's sort of the major difference, is that the Tecton provenance sort of records the build instructions, and there are many of them. And the SLSA provenance does let you do that in the arguments field, but it's sort of generic and builder specific. But that what we would like is we would like people to use build as code so that they can simply have a single entry point, which like points to the file that defines the instructions that got executed, because that makes policy evaluation a lot easier. Instead of having your policy say, like these like 20 steps must have been followed exactly, you can point to a single file under source control and says it must have executed this job from this file, period.
But a lot of the times that file is written by humans, not machines. The analogy I like to point out is package JSON versus package block, right? Take, for instance, GitHub Actions, right? You reference things at particular versions, but you don't have commit SHAs checked in for every action that you're evaluating. And what's coming out of chains is, not the sort of tags that are appearing, for the steps that are run. It is emitting digests of exactly the container images that were executed, right? So there is a difference between just saying this is what was checked in, and this is what was resolved and was run transitively across, everything, right?
I think that I would argue that the config file, number one, in addition to saying, hey, it was this file that was executed, that it's also referenced in the materials, and that it should have the specific commit SHA of that file, and then that the containers used in the build, those could, and I don't know if Mark has any other thoughts here, those could simply be referenced in the materials section as like, hey, I used these like 10 different containers here they are.
Yeah, I think the main thing is input versus like what was actually run, because asking folks to write the sort of thing that's fully resolved that machines generate and like check that in all the time, I see as one of the great failings of Bazel. I mean, if we can have machines generate those things and you do check it in like, lock files, then great. But like, I think a lot of folks will bristle with that in general if it has to be checked in all the time.
I think that I might not be entirely understanding. Like what we're asking for is like not the machine generated file that we want users to provide, but rather like the cloud build .yaml, which the user wrote in order to set up their CI/CD pipeline, that they were writing anyways to sort of automate their build.
Right, and so my point is that I would wager that the vast majority of cloud build.yamls reference images by tags, and I'm saying that is insufficient to evaluate policy against, because you do not have the digests of those things, so you do not know what those pointed at the point that the build executed, right? Whereas what Chains is producing is the resolved digests at the SHAs that they were executed at, which are immutable references, right? It's mutable references in the cloud build YAML versus the immutable references to images that were actually executed as part of the workflow. So, sorry, I'm a digest nerd, so this is I'm.
I think the intention of this. So first of all, the SLSA provenance, it's a 0.1. There's certainly improvements to be made. I think particularly around naming, like invocation versus recipe and other things like that, could be ported over. So I'm not trying to argue that like everything that went into the SLSA one is correct and everything Chains did was wrong. So first, the intention of the SLSA provenance is actually to resolve all those version IDs. So when you at least at SLSA 4, when you have a fully hermetic build, any input artifact would be identified by hash. So you would know all of the, I don't know the equivalent in Chains, but for like GitHub Actions, all of the actions that you used, plus everything that was fetched, you have like where it was fetched from, like with a Perl or something like that, and a hash. So I think that's the same in both. believe the main difference between the tecton chains provenance was in an intended use case. With the SLSA one, our intended use case when we wrote it, as Tom said, is to try to minimize the amount of information that you need to check. The idea being, if you're using GitHub Actions and you have the YAML file, if someone executes that in a faithful builder on GitHub Actions, then it will do the right thing, unless you have like some, I mean, it's doing SSL and everything like that. So it's pretty difficult to inject bad behavior when GitHub Actions is actually injecting that, because like the team has reviewed that full configuration. And like the policy would be like, did you actually build, did you kick it off from the right step? Because like you trust the builder will actually execute all the steps correctly. That's like the model that we were thinking of. With the chains, and you could argue with that, and I'm happy to discuss that. But with the chains model, I think the questions that they wanted to answer were different. Was not like what kicked it off, but rather what were the individual steps so I could go inspect them without having to fetch the source repo. Basically, they wanted to take some information from the source repo, possibly with runtime information, and embed it in the provenance so it's all there. So for example, I think the example that was listed was like looking for curls pipe to bash. If that's one of the scripts, then you would possibly be able to detect that. Now I have a question of like, well, why are you just recording the first level of step? If the step is run a bash script, you're not inspecting that and like go full down. But I think that was like the main difference of intention. Tom?
Yeah, so I think to the other point that like users wouldn't want to like write a build script that anchored every step at a particular hash, that like they want to use tags. I completely agree. Like the users want to use tags, and I think that the other thing, that the other side of that is that for SLSA policy, at least how we plan to use it at Google, that users will also have to write the policy that they accept, and like users will want to be able to like, and so users can like easily say this YAML file from this repo is what should have been executed, and you don't want them to have to say these 10 steps add like these 10 different Docker digests, right?
Yeah. So one quick thing on the way that we've been approaching it here is, so I think I largely agree with you on that one, where we're sort of taking it as the attestation, you know, we're taking at some level, but then there's a secondary thing, which is we could always go back and audit, right? We could always go back and sort of validate, hey, you said these materials prove these things.
Mm-hmm.
I'm trusting your signature that's true. But on a regular basis, you know, out of band, I can go back and audit that. And if I find that, hey, something doesn't seem right, I can go back and invalidate, you know, hey, you're signing stuff that I don't trust. But the key thing there being, at least obviously this works for us because, you know, most of the stuff we're doing with SLSA is for signing our own internal artifacts. But it's anyway, just wanted to say that I think that sort of thing seems important, because I agree, like, you know, we can go as recursive as we want, right, in validating all these things, but at a certain level we do want to get that high level quick thing that we can check, and then on an ongoing basis we can continue to sort of audit or have other third parties sort of add their signature in addition to that, saying that, hey, we audited their process, to then add that additional sort of layer there that we think that, yes, their SLSA attestations are correct.
I think maybe the takeaway from this discussion, which is what Matt said originally, which is we should probably go through and look at how to resolve the differences. And if we could come up with a format that works for both That's probably better than having two slightly different formats.
Right.
And also, if there's ways that we could change the salsa provenance to make it more readable, because like Matt said, initially the Tecton one connected better with him. Like we should fix that. That would be good.
I mean, and if there are other ones out there, right? Like it's worth sort of trying to rationalize, because I totally agree that trying to standardize around a common format that more folks can get behind is more valuable than everyone going their own direction and having to write policy against a million different formats. I totally agree with that. So yeah.
So
Hold on.
I just like
Very
to provide
quickly, the recipe field, like there is a sort of inbuilt like customization bit in the current salsa provenance, which you could definitely put prescriptive versus sort of descriptive sort of images of the build, not images, representations of the build. So I don't think there's I think the thing about the current salsa provenance is it's very not sort of prescriptive about what goes in it. There are customization points to permit this exact, or to solve this exact sort of problem that some build systems may have different models or may need different things. Yeah, sorry, Tom.
I was just going to mention that that an argument for having multiple different formats, which is supported by the bundle, is that like I can imagine a scenario where we say you should produce the salsa provenance, and then if you want, you can produce builder specific, very detailed information as well. There's I feel like there's this potential difficulty when it comes to a generic provenance format and all of the different builders that exist in the world that might want to record very specific, detailed information about exactly what they did, which is going to vary from builder to builder to builder. Trying to stuff all of that into one format that everyone can work on in the same way is likely very hard. My view was that the salsa provenance should provide enough information to evaluate some set of properties generically between all builders. And if you want to do more detailed things, like look for curl bash, like look for potential misconfigurations in a specific builder, that's a great use case for also producing this detailed record sort of tailored to your build system. And luckily, you can produce both of those attestations at the same time. You can stick them in an in-toto attestation bundle and propagate them together.
So, I mean, it might also be worth looking at what the common ground is and talking about extension mechanisms, right? Extension fields, right? Where you can, if we can find some common ground for the bits that we think will be common across a bunch of systems, right? And establish a common schema for that. You can also do something like have a mechanism for folks to extend the core schema with URL prefix fields or something like that, where it enters into territory where they are, defining their schema. So I can have, mapmore.io/whatever, and my tools sort of define the schema for that extension, so that So, but I'm wondering what that sort of common bit is, because with chains went in a completely different directions. Clearly, the extensions were not enough for what they were trying to do. So, define what we think is the common ground, and then show examples of how you would use the extensions to capture some of the other stuff. I think would be helpful.
Is the cloud native format that different?
It's been a while since I looked at the salsa one.
Yeah, I don't remember. I don't think it's very different.
No, it's just a change in the field that could just be put in recipe, if I'm remembering correctly. And recipe is exactly that, custom extension point that is freely defined for arguments. I think there is definitely room to look into converging.
It's just to accommodate that intact on the build file isn't like it's kind of baked into the.
I'd be curious if there are other people that are trying to implement like the salsa. That might have more feedback too on the formats.
I will probably have feedback in the next couple of weeks. I'm just starting to implement some of it now.
Cool.
I think there's definitely room to make customization a lot easier. I think that's something we should spend time on trying to make easier.
Yeah, I mean, I think that as part of the exercise, right, having lots of examples of how folks are using this and extending it to capture, metadata that they want represented outside of that core set, I think will be super helpful to avoid talking past or stuff like that as well. So.
Yeah, definitely.
Cool. We're gonna get kicked out of here. So any last minute topics? Excellent. I'm not hearing anyone mention SBOM in this Providence conversation. Am I missing something here?
That sounds like a good topic for the next meeting.
Yeah. Cool.
If you're interested, though, I'm currently doing it out of band specifically because it's not, as far as I can tell, not included. But I'm doing something similar, but just sort of using salsa and then separately also including SBOM validation.
All right, awesome. Thanks, everyone. This is a good discussion. Zach, were you able to record or? Okay. There's a YouTube channel. I'm not sure if you can put the record and I can move it over if that works. So we'll get this meeting figured out for next time. All right, have a good day, everyone.